Hi everyone, welcome to today's webinar. My name's Susanna Macbeth and I'm with South Coast Natural Resource Management based in Albany on WA's South Coast. I'd like to acknowledge the Menang Noongar traditional owners of the country on which I live and work. I recognise their continuing connection to land, water and culture and pay my respects to their elders, past and present. We do have people joining us from all around Australia today, so I would also like to acknowledge traditional custodians throughout Australia. So today's webinar looks at planting trees on farms and the impacts for biodiversity and natural capital. The webinar is part of a large multi-organisation research project, Sustainable Pathways to CN30, which is itself part of the Carbon Storage Partnership funded by Meat and Livestock Australia. Some of the work we'll talk about here today is specifically funded by Australian Wool Innovation, and I'd like to acknowledge their contribution. Planting trees on farms is not a new concept, but the reasons that people choose to plant and the design of plantings and choice of species has evolved and continues to evolve. In the work we'll talk about today, planting trees on farms was looked at as one of many interventions that could help reduce farm emissions, but crucially, it's also an intervention with great potential for biodiversity. That potential is what Dr. Carol Makani from CSIRO explored through his work on this project. Also joining us from CSIRO today is Tony O'Grady, who has looked at how climate, environmental and agricultural information can be usefully monitored through natural capital accounts. So just a few housekeeping points before we get started. The webinar is being recorded and will be distributed afterwards. Please ensure your microphone is turned off, but questions are welcome through the Q&A function that you'll see at the bottom of your screen. There is also a chat function as well, so if something's not working or you need to get our attention as speakers, please do put a message in there and we'll see if we can help. And if the webinar is disconnected for any reason, please rejoin via the original link. So just before I introduce our speakers, I am just going to run a little poll here just to get a bit of a sense of who's in the room, so to speak. So you should see on your screen now a poll which has 6 multiple choice questions. So we're keen just to get an idea of why people might have chosen to join the webinar, where you're coming from today, and also whether you're a farmer, whether you're a researcher or other. So I'll just give that a moment for you all to have a look at the poll. Now, I'm not getting any responses there, so I'm wondering if it's not working. There we go, starting to come through now. Thanks, everyone. I'll just give that a bit more time to give everyone a chance just to have a look at that poll and fill out your answers there. So this is particularly useful for our speakers to get a sense of where people are joining us from today, and also the capacity in which you're joining the webinar. So whether you're a farmer, government representative, researcher, etc., that's quite helpful. There's a couple of questions there that are particularly targeted at those who are farmers. So if you're not, then obviously you don't need to worry about those questions. Alrighty, thank you so much, everybody, for taking the time to answer that. It looks like we've got pretty much nearly everyone's answered the questions, so thank you very much for that. I'm just going to share the results of that on the screen briefly so that you can have a look and get a sense of who else is in the room, the virtual room. All right, so while you're having a look at those results, I will just introduce our speakers. So if I could get our speakers to turn their videos on, that would be great. Okay, so I'm here to talk to you today. We've got Dr. Carol Makani, who is Senior Research Scientist in the Macroecological Modelling team at CSIRO. Carell has led the biodiversity modelling for the Sustainable Pathways project. His work over the past decade or more has been focused on modelling approaches that improve our understanding of biodiversity patterns and dynamics at a community and regional level. Dr. Anthony O'Grady is Senior Principal Research Scientist in the Environmental Unit of CSIRO based in Hobart. And Tony's led much of CSIRO's work on natural capital accounting, with a particular focus on trialling and adoption of natural capital accounting and assessment in the private sector. So this work spans agriculture, forestry, and the resources sector, and it really opens the door to consistent reporting of natural capital across the economy. Tony's a member of the steering group for the World Economic Forum's Natural Capital Initiative and the Australia-New Zealand Working Group for the Science-Based Targets Network. And we also have Associate Professor Matthew Harrison from the Tasmanian Institute of Agriculture at the University of Tasmania. Matt leads the Sustainable Pathways to CN30 project team, and I'm going to hand over to him first to explain the background for this work. Thanks very much, Matt.
Thanks, Susanna. Let me know if you can't see that. So I lead the Carbon Storage Partnership, and I'm based at the Tasmanian Institute of Agriculture in Launceston. I acknowledge the Palawa and Gadigal people, the traditional custodians of the land upon which we live and work. The Carbon Storage Partnership is basically comprised of three main pillars, three main work areas, and they include carbon storage, which we're looking at practices and technologies for improving soil carbon, so comparisons between grazing management practices, for example, for improving soil carbon, and process-based modelling and machine learning technologies for improving soil carbon. We're looking at silvopastoral systems, so the interplay between trees and pastures and livestock, looking at productivity and profit and emissions, co-benefits of trees on farm, so if you're planting trees, what's the impact of those shelter belts or shading on productivity, and high resolution national progress towards CN30, which is MLA's aspiration for a carbon neutral livestock sector by 2030. The second main part is integrated management systems. And the main aim there is, well, if you've developed a practice for reducing greenhouse gas emissions, that's all very well, but what's the impact on productivity? What's the impact on profit? And what's the impact on biodiversity? So looking at sort of co-benefits and trade-offs associated with practices that reduce emissions. So we've looked at developing and improving carbon accounting tools as well as natural capital accounting tools. Tony will talk a bit about that today, and policy implications of carbon farming. And finally, we're distilling all of that into specific actions that farmers and their advisors can take to measure and improve carbon and biodiversity position on farm. So part of what we're doing is working with case study farmers, and Carell will detail this more shortly. And those farms are spread across the country, and they are deliberately chosen because they represent a whole bunch of different livestock production systems across Australia, as well as agroecological regions. So if you look at that farm in the centre, it's about 500,000 hectares, and they get about 160 millimetres of rain a year on average. And if you look at CAC2, the farm just above Brisbane or on the Queensland coast, it gets about 1,000 millimetres of rain a year, and it's only 750 hectares, so quite a big difference between them. And if you look at carbon sequestration, which we've simulated in a high resolution temporal way, we're going from about 7 tonnes of CO2 per hectare after 25 years in environmental plantings up to 110. So environment has a big impact on carbon sequestration of these trees. The other part that we looked at was spatially explicit biodiversity, and for that I will hand over to my colleague Carell.
Thanks, Matt. And I'll just share my slides. All right, great to be here. Talking about our work in this project is really focused on assessing the biodiversity of the case study farms and estimating potential benefits of revegetation actions on those farms. And I'm coming to you from Canberra, so Ngunnawal country, where I live and work, and pay my respect to the Ngunnawal people and all traditional owners around Australia. So, why are we interested in biodiversity? Well, it's an amazing natural asset that we have in Australia and around the world, and it's really under threat at the moment. So here's a couple of examples. The Living Planet Index, which is a global index, and Australia's own version of that, the Australian Threatened Species Index, and these are just examples of other metrics that show the same declining trend in biodiversity. And so this is a real pressing emergency for the world to deal with, and it's fair to say that agriculture has played a role in creating these declines in biodiversity around the world. But importantly, agriculture has a really strong role to play in helping to halt and reverse the declines. And that's really been the focus of this project. And so it's really about understanding capacity of revegetation and providing habitat back into landscapes and how that can support biodiversity into the future. So as Matt introduced, we have 14 case study farms that we examined around Australia, and they really are a diverse set, ranging from a couple hundred hectares to a couple 100,000 hectares, and across very large climate and rainfall gradients. So how do we go about assessing biodiversity for farms? There's obviously lots of ways to do this. Biodiversities are really quite a complex feature to try and characterize and quantify. So ideally, we go out to our place of interest, our farm, and go and directly record and measure all the species of plants and animals, fungi that occur there. That's a great way to understand what biodiversity really is on a farm. But obviously it has constraints. So there's only so many ecologists in the world, and getting them out to do field surveys isn't cheap or efficient. And so our approach in our team really relies on coupling best available information to provide consistent metrics for biodiversity at scale. And so I'll just briefly introduce how we go about that. So the first step is really to quantify ecosystem condition for each hectare pixel across Australia. And to do that, we use remote sensing, and we a bunch of other information that helps us quantify and estimate for each pixel how is the capacity of that hectare to support biodiversity changing for each year over time. So that's a key ingredient. Another really important ingredient is ecological data. So we put together very large ecological data sets from across Australia. We fill spatial gaps in those data sets to generate spatial expected biodiversity patterns. And those are patterns that we'd expect if in a pre-European non-impacted world, effectively. So we fill the gaps in biodiversity, and then we generate biodiversity indicators by combining our time series of ecosystem condition with our expected biodiversity patterns. And so for each year, we can then generate indicators that can be at a pixel level or some aggregated level, such as a farm in this case. This is what we call a habitat-based approach to biodiversity assessment. And the nice thing about it is that we can then also go into the future. So we can generate scenarios of future ecosystem condition. In this case, we looked at planting trees or revegetation actions on farms. And then we can generate the same biodiversity metrics or estimate their changes into the future under a particular scenario. So for this work, we looked at three biodiversity indicators. The effective habitat area is really a summary of that ecosystem condition data. So what we do is we look at the total area of condition-weighted habitat that a farm is providing. Threatened species habitat indicator is really focused on how well a farm is doing in providing habitat for nationally listed threatened species, and it has units of species hectares. And then our final indicator is really much broader in terms of biodiversity and quantifies the benefit of the habitat on the farm for promoting plant species persistence right across Australia. And the important aspect of that final indicator is really to consider the context in which a farm sits. So a farm might be really important, particularly important in terms of supporting biodiversity if it's sitting in a landscape that's been quite heavily degraded in terms of ecosystem condition. So here's an example of our results and what we call a monitoring view on the world. So looking at past to present change in our biodiversity indicators. This is for one of the example farms. And so for each of the indicator, you'll see there is a declining trend over time for this farm. Here we've got different units on our indicators, but they all provide a consistent metric over time and across different farms as well. And so when we look at all of the case study farms, all of the 14 case study farms, we can combine those metrics in terms of their relative change to the most recent observation, which is 2020. So here on these figures, each of the grey lines is a farm, and the black line is the mean across all farms. And so you see for the first indicator, effective habitat area, there is a slight decrease, a bit more of an obvious decrease over time for the case study farms. For the threatened species habitat indicator, the average is primarily driven or strongly driven by an outlier farm that you'll see that had a very, very large decrease in threatened species habitat, and no real obvious temporal trend in terms of the benefit on farm for plant species persistence. So some slight differences in the biodiversity indicators, which tell a different story in terms of the components they're reporting on. Now, as Matt introduced, the real focus of the project was to look at and examine and quantify the potential benefit of revegetation on providing farm habitat. And so for this scenario, we worked with farmers to help identify 10% of the farm area that could potentially or would most likely go into a revegetation action if they were going to implement one on their farm. And so here's an example image of where the orange areas, orange polygons we call them, are the areas on this farm that the farmer identified where they would implement a revegetation action. And so that was mostly tree planting, but for the more arid areas that we implemented what we call a natural regeneration action, where we just remove grazing and let the natural vegetation recover. And we implemented this scenario over a 30-year period from 2020 to 2050. And this is an example of the response functions we apply. This is for an environmental planting. So our expected change in ecosystem condition over time depends on the starting ecosystem condition for any pixel, and will vary over time with that starting condition. So what were the potential benefits of the revegetation action? So here's another example. This is the same example farm I showed before, and it's really highlighting the potential benefits of revegetation actions on farm. So we see in orange here again is the areas identified by the farmer where they would implement the revegetation actions. And we can see in the figures large increases in our biodiversity metrics over time following the revegetation, and they're all recovering and exceeding those historic gains. And so this is really I guess what we want to see, that such revegetation actions can turn around past declines and can really add new improvements for biodiversity across farms. When we summarise across farms, we see a similar trend. So there's real large benefits, varying a little bit with the indicators, but consistent across them in that the gains possible in the revegetation actions over time are really substantial. Although I will note they do take time to be realised, and so you'll notice for in the short term after a revegetation action we might not have generated such improvements, but over a longer time, as the vegetation grows, it provides more habitat for biodiversity, and therefore you have greater benefits for biodiversity. So just in summary, we found in this work substantial gains possible through revegetation, and in most cases able to recover any more recent past losses in habitat and our biodiversity indicators. Obviously, as Matt introduced at the beginning, revegetation actions are going to have implications for other features as well. So for production, for profit, for ecosystem services, and all of those other aspects would need to be considered, obviously, in considering the implementation of these sorts of revegetation actions. There's real benefits in this sort of habitat-based approach, and the biodiversity indicators we've applied here, they're very efficient to implement. So the same analyses can be implemented for any farm across Australia, and provide, I guess, a complementary view to going out and doing on-farm field surveys of types of species that we might find and how they would change under revegetation. And as I mentioned, we can apply similar assessments and analyses for other farms in Australia, and all of these analyses are actually implemented using a tool that CSIRO has developed called LookB, and that's freely available for people once you register to play with and to explore your own areas of interest and how different actions might influence the biodiversity indicators across the area you might be interested in. That's all I have to talk about today. So now I'll pass it over to Tony.
Thanks, Carl. And good afternoon, everyone. Thanks for giving me the opportunity to discuss some of the work that we've been doing on natural capital within the project. Before I start, I would like to acknowledge the Muwinina people from Nipaluna Hobart, which is the lands where I live and work. I'm not going to speak specifically about the interventions that have been discussed so far today. Rather, I've been asked to present some of the work that we've been doing aimed at driving consistent and comparable reporting on natural capital. And so while I will today present examples of how we applied this thinking at a farm scale, it is worthwhile noting that what we've been doing, we've been trying to develop ways that we can apply this to all different sectors of the economy. So, and what we're hoping to achieve really is to work with ways that will drive consistency, transparency, and comparability in the reporting of natural capital right across different sectors. And I think this is going to become increasingly important, particularly over the next 5 years, as there's been a much stronger focus on the reporting and disclosure of organisational impacts and dependencies on natural capital, and that focus is being driven by international accounting standard setters. And so while it's true that these requirements will largely be focused at large corporate organisations, the strong focus that they'll have on reporting across the value chain means that these changing expectations will have implications right across the supply chain and right across the economy. And so I think it's important for us as a research community that we're working on ways to drive efficiency in this data collection and to make it as accessible as possible. So there has been quite a lot of focus on natural capital in recent years, and so it is worthwhile just defining some of the key concepts, because while there has been a lot of focus, there's also been a lot of confusion. And so, I mean, put simply, natural capital is really just the stock of the non-renewable and renewable environmental resources that come together in unique ways to create ecosystem services that create flows of benefit for society or for organizations. And so, and natural capital accounting is simply the process of just calculating and measuring the stocks of those environmental and ecosystem resources, and measuring those ecosystem service flows and using them as a basis to create a value to value the underlying ecosystem assets. The other thing that comes up quite a lot in this field is this concept of natural capital assessment. And although the concepts are very similar, there are some quite differences. So where natural capital accounting focuses on measuring the stocks and flows of natural capital under an organization's control, a natural capital assessment is really a systematic examination of how an organization or a farm, for example, might impact or depend on those stocks of natural capital, and more specifically, what are the risks that those impacts and dependencies might create for that organization. So it's really about trying to understand how an organization might respond to a changing risk profile associated with impacts and dependencies on nature. So in practice, what does this look like? So if we take the definition of an asset, an accounting definition of an asset, to be a resource controlled by an entity from which there are expected to be future flows of economic benefit. Then from an existing accounting perspective, we have quite a limited view of what the assets are in agriculture. And so, typically we think about, like, the existing accounting perspective views assets as falling under, the livestock or the cultivated plants or the property, plant and equipment that a farm has. But really what natural capital accounting is challenging us to do is to take a much broader perspective of the asset base on a farm, and to think about the components of nature that make up the farm's asset base, and to think more broadly about the sorts of the flows of ecosystem services that these natural assets create, and that the farmer directly benefits from. And so, from in the context of today's presentation, trees can be conceptualized as an asset class that provide a range of beneficial ecosystem goods and services. And most people on the call will understand the concept of the shelter benefits from trees. The work that Krell talked about for the capacity for providing habitat for biodiversity or increasing forage and fodder production through time. And so none of this is actually a new idea. But what natural capital accounting is trying to do is to provide a way to formally recognize this broader set of assets and the associated goods and services, and gain a better understanding of the contributions that these natural capital assets are making to the productivity of not only a farm but of the region more broadly. So in practice, it's conceptually it's a relatively simple concept. It involves measuring the extent or the stock of the underlying environmental or ecosystem resources. developing in a spatially explicit way, developing ways to measure the condition of those underlying assets, and then identifying the types of ecosystem services that those assets are generating. And it's these ecosystem services that the flows of these ecosystem services that provide the value, provide the basis for evaluation in terms of monetary context. And so, so while the concept itself appears to be relatively simple, the challenge of deciding what to actually measure can seem infinitely large. And so when we were framing up this particular project, we did a review of the existing sort of sustainability and natural capital risk assessments for agriculture and livestock to really try to narrow down on the types of things that we might want to measure. And ultimately, what we find is that in terms of natural capital, this really comes down to 6 key indicators. And these 6 key indicators are really well aligned to international reporting requirements, and it's no real surprise that these come up as material issues for agriculture, as they're strongly aligned to the main drivers of nature loss, which include land use change, resource use, climate change, invasive species, and pollutions. And so what we've been doing as part of this project is compiling information and data from across these different themes, so that we can start to develop a more integrated way of expressing how a particular farm is performing in terms of its natural capital. But unsurprisingly, this creates quite a significant amount of data, and here we have just a screenshot of an example of a type of database that are being generated for the different farms across Australia. And across the tabs, we can see, we've got all sorts of data on condition, carbon stocks and greenhouse gas emissions, biodiversity, soil, water, and climate, and a whole lot of supporting information. And the challenge is that what we're collecting for each of the farms is spatially and temporally explicit data on all of these different themes. And so we can look at the extent of different assets across the farm. We can start to think about what's the condition of in this case, the pasture across the farm in spatially, and we can start to bring in the types of biodiversity indicators that Krell was talking about earlier. Even looking directly at spatially measuring, spatially estimating evapotranspiration across the farm, and also starting to compile a range of climate indicators and things like this. So again, this is a lot of information, and it can be quite overwhelming. And so one of the things that we've been thinking a lot about is how do we actually summarize this data and report it in a much simpler way. And at least one of the ways that we're doing this is through the use of dashboards. And so what we have here on the right is really what is a proof of concept, where we can start to present data for individual farms across the different themes that we've identified as being potentially material to our farms, stakeholders, or customers, and things like that. And so here we can start to compile indicators on the land, the carbon stocks and carbon emissions across the farm. We can present data on the different biodiversity indices that Krell was showing before, the different types of water use on the farm, and also we can start to bring together a range of climate indicators. And so I think it provides a pretty nice summary of what is a pretty extensive spatial data set across the farm. And I'll just put out there that I'm actually going to be working with Sue Ogilvie in the future and in the next few weeks to try and think about how we might all come together and come up with an agreed dashboard that we might be able to apply more broadly across, beyond this project and across agriculture more broadly. So, and the other thing that we've been working a lot on is the presentation of this information within more formalized accounting and reporting frameworks. And on the left of the screen at the moment here are examples of sort of impacts and dependency statements that are directly aligned to the recommendations of the Task Force for Nature-related Financial Disclosures. And on the right is some work that we've been doing around presenting natural capital in exactly the same way that financial information is presented for any organization. And so, you know, what we can see, what we can do is actually use existing accounting standards to come up with natural capital income statements, natural capital balance sheets, and natural capital change statements for different farms. And the aim of this type of reporting is that it actually presents natural capital data in a way that's consistent and comparable. And so then you can start to be able to compare the natural capital between different reporting periods, or between different entities, or between different sectors of the economy. And so really what we've been doing as a team here in CSIRO is really starting to take the concepts that emerged internationally around environmental accounting and natural capital risk assessment that is being captured in things like the Task Force on Climate-related Financial Disclosures and the Task Force on Nature-related Financial Disclosures, and start to translate that into existing accounting standards and approaches that most organizations are familiar with, and really trying to get to a point where we can produce one natural capital report for a farm that provides a comprehensive statement on a farm or any other businesses natural capital. And just a bit of a plug for the different we've been producing a whole bunch of guidance and handbooks on this as we've been going along to sort of try and communicate these concepts more broadly. And so with that, I think I am meant to hand back to Susanna.
Yes, thanks very much for that, Tony. So yeah, thanks everyone. We've got time for a few questions, but we do have quite a lot already in the Q&A and in the chat. So I have collated some of those to cover hopefully a few questions at once. But before I go to questions, I do have another poll for you. So just bear with me while I launch that one. Now, this poll particularly, we're quite keen to get a sense of other information that you might be, I guess, looking for after this webinar. Now, I think there might be a question in there that refers to the Q&A, which we haven't done yet, so apologies about that. But I'll just leave that up there for a moment for people to start filling out. And in the meantime, I'll start collating some of these questions together. So, Karel, do you want to turn your video on as well? Cool, and we'll just get all of us on screen. So there's quite a few questions that came through in the chat and the Q&A about measuring other outcomes for agricultural productivity. So, for example, soil condition improvement, water retention, benefits for livestock. So perhaps either Karel or Matt, you'd like to speak briefly to that around other benefits that come from the planting trees on farms?
Well, I'll let Karel do the biodiversity stuff, but there was another project in the Carbon Storage Partnership called Co-Benefits of Trees on Farm, and I think Rod Keenan was one of the attendees. I'm not sure whether attendees can talk or not, but he would be the man to address that question. Rochelle Meyer was also involved. So they were looking at things like if you've planted a shelter belt, what's the impact of reduced wind chill on reduced land mortality, which is a productivity co-benefit? If you're out in the hot arid zone, what's the impact of shading on reduced heat stress and heat stress related mortality, which is again a productivity co-benefit? But there's a whole bunch of other things, and I know Rod is probably shouting at me right now. He would say non-monetary benefits, pollination, aesthetics, property appreciation, reduction in wind, a whole bunch of other things that are not necessarily attributed to an economic value. So I'm sure that doesn't do justice to the question, but
I can actually, there is a fact sheet on that produced by the by the co-benefits team. So I'll find that and pop that in the chat, which will help to answer some of those questions that people have asked. Yeah, thanks for pointing to that, Matt. That's useful. Now, a few questions also about the choice of sites so we talked about the 10% trees on farms and that being identified by the farmers as to where they wanted to plant that 10% trees. Again, Matt or Karel, if you could touch on this, how the farmers chose those locations, and was there any input, for example, from ecologists on how those choices were made about where you did that modelling?
I can take that one. So they were selected in a conversation with an ecologist, but we didn't direct the farmers to which areas would gain the most biodiversity benefits. So it was really focused on, in terms of their farm property and the mix of land types, where they would most likely think about revegetating or planting trees on the farm, and really guided by that decision-making process.
Cool, thanks, Karel. And someone else had a question about what the assumed survival rates are for planting vegetation in this kind of scenario, or does that depend on the locations?
That is a really good question, and in this case, we've just assumed that the plantations have been given the appropriate support to survive and grow. So we assume that they have been successful.
Okay.
But that's right, that in some cases might require additional support, like watering during droughts or something, to keep trees alive.
Cool, thank you. So there are quite a few questions there's a couple of questions here about the natural capital works. I'll just switch over to Tony briefly now for a couple of questions on that. So with regards to the dashboard, firstly, what tool is it using for carbon emissions measurements? And is there any alignment with the Australian agricultural sustainability frameworks?
So I'll answer the second part of that. Yeah, I mean, effectively, we have tried to directly align it, and that was the work we did in terms of looking at what's material for those Australian agricultural sustainability frameworks, and so I think there is pretty direct alignment there. Matt can help me out on the tool there for the emissions. I think it was the SP-GAF tool that we used in that work. I was a data ingester at that point rather than pulling that data together myself personally, but pretty sure it was the SP-GAF tool, wasn't it, Matt?
Yeah, it was the GAF tool, which is aligned with the Australian National Inventory. Yeah,
and all the carbon stocks for the farms were modelled using a sort of proprietary software, Flint Pro, for all of the farms across Australia as well. So each farm was done in a consistent way for both the carbon stocks, changes in carbon stocks, and the emissions associated with each of the farms.
Flint Pro is basically a spatially explicit version of FullCam, which FullCam simulates tree growth basically and all the carbon pools and fluxes, so bark, sticks, roots, litter flows, soil carbon. It does that for each pixel, and then Flint Pro does that in a spatially explicit way.
Cool, thanks Tony and Matt. So one of the questions here is whether or not this kind of reporting format is available for farmers and businesses to actually use. And I think that's probably a key question on a lot of people's minds, is how accessible are these kind of reporting frameworks for farmers now, or what's the kind of options in the future?
Yeah, I think that's a really important question. And as I sort of mentioned, I think it's going to be quite imperative that we can make this widely available and cheap as well, but it's not ready yet, but it's definitely part of my I suppose part the impact to try and make this accessible to as many people in Australia as possible. Really, we're at the point where I feel like we've sort of tested this across a range of sectors and demonstrated that it can work, and we can start to produce this sort of information consistently and coherently. And we've really relied on public data and nationally available modelling to do this. So I think we can get a long way, but yeah, we still need to find a way to actually build them into tools that people can just download directly into their desktop. So there's still some development to be done on that front there, but hopefully that's not too far away.
Yeah, it seems like there's a lot of different, I guess, organisations working on trying to develop something, and in both the private sector and elsewhere. And so it's a matter of whether there's going to be a whole lot of different processes out there and how they can be brought together into something that's consistent. Okay, there's about 15 questions still in the Q&A. So I think some of those.
Can I interrupt for a second, Susanna? I was just going to say, one of the questions, and this question is quite common, is how did the 10% number come up? The 10% refers to, Carel mentioned planting 10% of the farm area to trees. That was simply a standardised number to standardise across farms, because we're going from 750 hectare farm to a 500,000 hectare one. And we wanted to look at the relative impact relative to farm size, including carbon sequestration. So we in fact did a per hectare basis and then just scaled that. So that was just a number. So if you knew what the per hectare value was for the change in biodiversity or carbon, you could scale that.
Okay, thanks, Matt. And I think there's one question here that I think a few people might have, which is about the carbon benefits from planting trees on farms. Matt, do you want to speak to that just briefly?
It ranges depending on where you are, predominantly driven by climate, mainly rainfall, to a lesser extent temperature sort of thing, and frequency of heat waves. So the numbers that we simulated for those farms, and that was done, as I say, in a spatially explicit way, so done spatially, but it's also done temporally. And so by that I mean what happens on one day is dependent on what was there on the day before, so it actually grows like a real tree in situ. So we simulated values that range from about half a tonne of CO2 equivalents per hectare per year, which were the dry ones in the centre, up to 17 tonnes of CO2 equivalents per hectare per year, which were some of the farms in New South Wales. So it's very much dependent on the climate and to a lesser extent the soil type.
Cool, thanks, Matt. And it's worth saying that there will be more detail of those results emerging fairly soon.
Yep.
And also across the other interventions that have been modelled as part of this project. So Jenny asks, was there a biodiversity difference between native and non-native vegetation? Now, as far as I'm aware, all of this modelling is based on it being native vegetation. And the next part of the question is, how do we persuade government to incentivise planting rather than allowing 40 hectares of clearing per year? Now, I think that's quite a broad brush question, which the natural capital frameworks also might have something to address this as well. Any response there from anyone on the panel?
Well, I can answer the first one. And in terms of incentivising farmers, that was the intention, whether it actually plays out that way or not, of the nature repair market, which is one of the first markets that was legislated, or so I'm told, which was December 2023. Where landowners effectively will be paid to restore and or conserve biodiversity on farm. But Carel and Tony might have other thoughts.
Not on that particular point, but I think there are differences in terms of biodiversity outcomes that you get from the planting configurations that you put in place. So clearly, environmental plantings are going to have a much greater biodiversity benefit than, say, plantations. But then again, whether that's important to you or not will depend on the sort of objectives for the farm. You might be more focused on trying to reduce your carbon, sort of inset your carbon emissions and things like that. So, certainly in a parallel project that I think, and Carel can comment more, we have there has been a bit of work done on looking at the biodiversity benefits associated with different configurations of trees on farms, whether they're exotic pines, native hardwoods, or environmental plantings. So there are differences. The actual overall benefit for the farm will depend on the extent, the configuration, and the broader objectives for the farm as well. So.
Yeah, absolutely. Every farm is different, and yeah, or there's an infinite number of options effectively, and they'll all have different outcomes. But certainly, as Tony's saying, that the environmental plantings, so more of a restoration planting, is going to have bigger benefits for biodiversity.
I think that kind of segues a little bit into another question we had, which is about a cost estimate, because if we're talking about it, very much varies farm by farm, and so too, I imagine the costs would vary as well. So I'm actually not sure whether that question was about the natural capital accounting or about the planting of trees on farms. Do we have those kind of figures for either of the work you've done, Tony or Carel, around how much it actually costs?
So we have this, Susanna. So this was, I'm not sure whether you can see my screen or not, but we did do the costs of planting trees, and we derived that data from a publication, Summers 2015. So the colours are basically cost per hectare. So they go from about $3,000 per hectare. This is the total costs of fencing, labour, establishment, everything else, up to about $8,000 per hectare. And then when you add in the costs of, when you add in the potential returns of carbon markets, most of them are negative. That's after 25 years, depending on where you are. So they go from about nothing for one farm, or cost of $10 per hectare, to $900 a hectare. That was for a very small farm. And then that's at the current carbon price of $38. And if you go up to $100, which carbon prices may be expected to rise in future, you start to see more profits associated with income associated with carbon. And that's not counting any potential income if you were to monetize biodiversity. So if carbon prices go up, depends on where you are and how much the trees grow.
Cool. Thanks, Matt. Okay, there's also been a couple of questions about best practices around tree planting. And I think for that, it's very much dependent on where you are. So as we've talked about, this work is all across Australia, and the actual guidance on the best ways to plant, best practices for biodiversity, and how you prepare for planting are very much geographically dependent. So for the people who are asking about that, we'd certainly point you to your local organisation. So that's to your local NRM organisation, or your local land services, or catchment management authorities, depending where you are, and also, of course, your land care groups. They're the ones that are going to have that advice that's really, I guess, localised to your area. And I'd probably also point you to Sustainable Farms work as well for detail around planting design, which is applicable to southeastern Australia especially. Okay, so let's see what else we've got here in terms of questions. Sorry, Matt, looks like you've got one you want to raise.
I can ask one just in the meantime. Great question for Carel was, someone asked it early on, was the number used for benefit for plant species persistence was very small, 0.0004. Can you explain that further, please?
Yeah, so that is the estimated effect of the habitat on the farm on the total number of plant species in Australia. So it's less than a species. So obviously Australia is big and a lot of farms are small. Indeed, the metric can be less than one and a lot less than one. For our larger farms, so the 500,000 hectare farm, I think from memory, the number was 2. So if you removed all the habitat on that farm, then we'd estimate to lose 2 plant species in Australia. So it's a comparable metric that accounts for the role of every location in supporting Australia's biodiversity.
Thanks, Carel. The other thing I was going to say is it's the relative change over time that is really important. Is it going good, or is it improving, or is it getting worse? That's particularly important, rather than the absolute number. Just following on from that, Alyssa Rawlings asked an excellent question, and she said, has this research been published, and is it available? So Tony has just published a paper on what he talked about. It's in press now on natural capital and grazing systems, related anyway. And Carel has also just published, well, publishing a paper with detailed scientific assessments of the research that he showed today. So in time, we'll be able to share that.
Cool. Thanks, Matt. Now I'm just going to ask one more question and then we'll wrap things up. So James asks, have you considered native browsing pressure and or costs of managing in relation to planting trees on farms?
Our biodiversity assessment didn't. It effectively assumes that you are managing those sorts of factors to enable the planting, in this case, to grow and to provide habitat for biodiversity. So I guess there's some implicit assumptions in our scenario along those lines. We didn't examine scenarios like removing feral grazers, although that is also an implicit assumption in our natural regeneration, revegetation for those more arid environments, is that not only are you removing livestock from those areas, but you're controlling any feral herbivores as well.
Cool. Thanks, Carol. All right, is there anything anyone else from the panel would like to raise, any other questions that you would like to respond to, knowing that we don't have time to answer all of them before I wrap it up?
Susanna, were you going to share the results of the poll or not?
I can do. Let me just...
I can if you want. Just in
case.
No, it
should be...
You're sharing now?
Yeah, should be visible now.
So just quickly, I think some people might find this interesting. Most people quite a few people learnt quite a bit from the webinar today. A lot of people said that they'll do further research on biodiversity, more than 70% of people, which is interesting. The most interesting parts of the webinar, well, even spread between natural capital and biodiversity, as well as, to a lesser extent, practical implications that people can take to improve biodiversity. I really need more information about, well, that was even spread, biodiversity, regen ag, natural capital, profitability, soil carbon, lots of things. And on a rating out of 1 to 10, 1 being terrible, 10 being excellent, most people rated it between a 7 and an 8. So not bad.
Thank you, Matt. Always good to get real-time feedback. All right, so thanks very much to everyone for their time today. So to our speakers, but also to all of you in the audience for taking the time out of your day. Please do stay tuned because there are more results to come out of the Sustainable Pathways work. And also there are questions we didn't get to. There's questions that require perhaps a more thoughtful response than we're able to give today. So for those, please do feel free to reach out to us. So I will put my email address and Matt's in the chat. So don't hesitate to get in touch if you have further questions. And also to keep in touch with the work that's coming out of this, please do follow Tasmanian Institute of Agriculture or South Coast NRM on social media, because we will continue to share results, webinars, fact sheets, etc. over the next year or so. All right, I think that's all from me. So thank you, Matt, Carel and Tony. Thanks again to the funders, MLA and AWI, and to everyone who's joined today.
Thanks for everyone for attending. Thanks, Susanna.
No worries. Bye.